Welcome. In this lecture, we're going to talk about the concept of role and how role is used in Unreal Engine multiplayer games. This includes the concepts of local role and remote role and how the two are different. And we're going to create a special widget that we can display above our character to show its current role so we can get a better grasp of role and how we can use it. So let's talk about network role for a minute. In a multiplayer game, there are multiple versions of any given character controlled by a player. If you're a client connected to a server, then the character that you're currently controlling exists on your machine, but there also exists a version of your character on the server. And if there are more than two players in your game, for instance, you have other clients connected to the server, then there's a version of your character on that client's machine. So in a 3-player game, there are 3 copies of your character, one on each machine. So it becomes important that we know how to distinguish which version of the character we're dealing with in the code. To sort this out, Unreal Engine has the concept of role, and there exists an enum called eNetRole that has several enum constants that we can use to identify the role of any given character or pawn. eNetRole has the role authority enum constant, and this role is assigned to pawns that exist on the server machine. Since Unreal Engine uses the authoritative server model, we consider any pawns that exist on the server to have the role of authority. Now, eNetRole also has a role of simulated proxy. When it comes to pawns, these are the versions of any character or pawn that exist on a machine that is not controlling that pawn. Now, your character or pawn that you're currently controlling on your machine has the role of autonomous proxy. Now, keep in mind that there are multiple versions of your pawn or character, one on your machine and one on each other machine that shows you on the screen. So when you're controlling your pawn on your machine, that version of your pawn has the role autonomous proxy, assuming you're not the server. If you are the server, then your pawn has role authority, as it exists on the server. Now, if you're playing with other players and you see a version of the character or pawn on your machine controlled by someone else on another machine across the network, then you're looking at the simulated proxy of that character or pawn, whether that pawn is controlled by another client or controlled by the server. Now, eNetRole also has role none for actors that don't have any defined role. So let's jump back into the editor and create a new C++ class, and this will be for a widget that we can display above the head of our character. So I'm here in the C++ classes Blaster folder. I'm going to right-click and make a new C++ class, and I'm going to choose All Classes. Now, I'd like to make a C++ class based on user widget, and that way we can drive the C++ variables of our user widget. So let's create this widget. Let's click Next. And I'd like to stick this in its own folder. I'll simply call this folder HUD. And I'm going to name this Overhead Widget, as it will be displayed over the head of the character. So let's click Create Class. Okay, so we'll hit No to this familiar message, and we have our Overhead Widget here. Now, of course, in the C++ class, I can remove that HUD part of the include to get rid of the compiler error. Now, we have this user widget. And we're going to use this as the parent class for the widget blueprint we're going to use to show the role above our character's head. Now, this widget is simply going to have a text block. So the type for this text block is going to be uTextBlock. Now, let's create a public section here. And in the public section, I'm going to forward declare uTextBlock. That's a uTextBlock pointer, and I'm going to call this display text. Now, we can set the display text for this widget that we'll create a widget blueprint for. Let's go ahead and create that widget blueprint. So here in my blueprints folder, I'm going to make a new folder called HUD. And in the HUD folder, I'm going to right-click, select User Interface and Widget Blueprint. And I'm going to call this WBP Overhead Widget. And this is going to be a simple widget blueprint. I don't need a canvas panel. All I really want is a text widget. So I'm going to select text and drag it in and resize this text. Now here in overheadWidget.h, I have a variable called display text, and it's uTextBlock. So my variable here in the widget blueprint has to have the same name as that C++ variable. So I'm going to call this display text. Now I'm going to take the font and set it from bold to regular and change the justification to center. So that way it's nice and centered. Now we can control the text for this text block from C++. And the way to do that is to give our display text a U property with a particular specifier. So let's give this a U property, and that specifier is meta equals, and in parentheses, bind widget. Now what this does is it associates this C++ variable with that text block in the widget blueprint. So let's compile our C++ code. And with our code compiled, back here in our widget blueprint, we can reparent the blueprint so that its parent C++ class is our overhead widget C++ class. We do that by going to the Graph tab and selecting Class Settings. And here under Class Options, we see Parent Class. Now, we just created this based on User Widget, but we can change this by opening the dropdown and selecting Overhead Widget. Now that this widget blueprint is parented to the overhead widget C++ class, and our C++ class has a uText block variable called displayText with the meta specifier bind widget, any changes we make to this C++ variable will affect our displayText text block. Now, if you're going to do this, it's very important that the text block here in the widget blueprint has the same exact name as the C++ variable. Otherwise, this won't work. Now, I see that my widget has resized. I'm going to size it back to roughly the size that I need for this text block. So now we just need to add some functionality to the C++ class that's driving this widget. So here in the C++ class, we're just going to add some basic functionality. Now, I'd like to override a virtual function inherited by user widget. This is a protected function, so I'm going to add a protected section, and this is a virtual function returning void called onLevelRemovedFromWorld. Now, onLevelRemovedFromWorld is going to be called when we transition to a different level or leave the current level, and this allows us to remove this widget from the viewport. Now, onLevelRemovedFromWorld takes a uLevel pointer called inLevel and a uWorld pointer called inWorld, and this is an override. So let's go ahead and make a function definition for this. And here in onLevelRemovedFromWorld, we can simply call removeFromParent, which will take this widget and remove it from the viewport. And we do need to call the super version of this, so we're going to call super onLevelRemovedFromWorld. And we need to pass in inLevel and inWorld. So that'll clean up our widget and remove it from the viewport so it's not still there. Now in overheadWidget.h, I'd like to make a function to set the text for our displayText text block. And this can be a public function. I'm going to make this a void function called setDisplayText. And this will simply take an f string. And I'll call this text to display. And then we can use that string to set our displayText value. Let's make a function definition. And here is where I'd like to set the text for displayText. So I'm first going to make a quick check to see if displayText is valid. And if it is, I'm going to take displayText and use the function setText. This function will set the text for this text block. Now, since we're using the text block data type, we need to include the header file for that. And the text block header is in components/text block, and that's a header file. So now we can call setText, and this takes an ftext, so we need to convert from fstring to ftext. Now we can use the ftext static function called fromString and simply pass in this text to display. So now we have a handy function that we can pass an fstring into that will set our displayText value. Now I'd like to make another function that will figure out the network role of our character. So let's go to overheadWidget.h and make another public function. And this will be a void function, and I'm simply going to call this showPlayerNetRole. And I'll add an input parameter to this of type aPawn called inPawn. And that way we can call this function from anywhere, such as on our character, and pass in a pointer to the character, and then we can figure out the net role here. So let's define this function. And here in show player net role is where I'd like to get the local role of the in pawn. A player's role is an enum value, and that enum is eNetRole. So we're going to make a local variable called local role, and we're going to set it equal to in pawn get local role. So get local role is a function that we can call from a pawn to see what its local role is. And of course, this local role is going to be different depending on the machine we're calling it from. Now, using this information, I'd like to call our setDisplayText function to show that role. So I'm going to make a local fString variable, and I'm going to call this role, and I'll set the value of role depending on our local role. So I can use a switch statement here. So I'm going to switch on local role, and I'll have several cases here. Now, the first case is going to be when local role is eNetRole authority. And as soon as I hit the double colons here, I see the different enum constants that eNetRole can take on. We have authority, autonomous proxy. There's the role max, which is something you'll see in most enums, that default max. And we have role none and simulated proxy. So we're going to choose role authority. And if our role is authority, we're going to set the role string equal to an fString with the value authority. I'm going to add my break statement here so we don't cascade into the next case. Now, we're going to have several cases here. I'm going to paste this and change it from role authority to role autonomous proxy. And in this case, I'm going to set role to the string autonomous proxy. Let's add another case here. And instead of autonomous proxy, I'm going to use simulated proxy. And in this case, I'm going to set the role string to simulated proxy. And a pawn shouldn't have its role be none, but we're going to handle that case anyway. So if the role happens to be none, we're going to set the string to none. So after this switch statement, our fString role will be set according to the value of local role. Now I'd like to format a string, so I'm going to create a new fString called local role string and use fString printf. And here for the text, for the formatted string, I'm simply going to say local role %s, and for that string, I'm going to pass role. And of course, this is an fString, so we need to use that asterisk overload to get a C-style string. And now I have a string called local role string, and I'm going to set our display text to have this string value. So we created a nice function to set this text called setDisplayText, which takes an fString. So we can simply call that. We're going to call setDisplayText and pass in local role string. So now if we have a widget of this type and we call showPlayerNetRole, we just need to pass in the pawn that we'd like to display the role for. So that's great. We just need to add this widget to our character. So let's go back to Blaster Character. So here in Blaster Character, I'm going to add a couple of variables so that we could create one of these overhead widgets. So I'll stick these down here in the private section. And I'd like to use a widget component for this. So I'm going to forward declare a uWidget component called overhead widget. And I'll give this a U property. And I'll make this edit anywhere so we can set it from within our character blueprint. So now we have this overhead widget, which is a uWidget component. Let's go ahead and go back to blastercharacter.cpp and create this in the constructor. So down here at the bottom, I'm going to say overhead widget and use create default subobject. And this will be a uWidget component, and I'll give it a name overhead widget. And I can simply attach this to the root component. So I'm going to say overhead widget, setup attachment, and simply attach to root component. Now we're using uWidget component, so we need to include that header file. So let's go to the top, and this is going to be in components/widget component. So we got that header file. All right, so we've added our widget component to the Blaster character. Now our function showPlayerNetRole, I'd like to call this from blueprints in the character class. So let's make this a U function, and I'm going to add blueprint callable. Now before we compile and test this out, I'm going to head back to Blaster character, and since we're going to call this, and since we're going to access our widget from blueprints, we should at least make it blueprint read-only. And if we make this private variable blueprint read-only, that means we need meta allow private access equals true. And if this is new to you, all this means is that we're exposing this variable to blueprints. We can't use blueprint read-only or blueprint read-write on a variable that's private in C++ unless we add this meta specifier. So now we can use blueprint read-only on this variable even though it's private in C++. So we can compile this. Now here in Blaster Character, here's my overhead widget. I'm going to select that and change a few properties in the user interface section. I'm going to change space to screen, and for the widget class, I'm going to choose WBP overhead widget, and I'd like to check draw at desired size. That way we don't have to manually set the size for this widget. So our overhead widget is set, and I'd like to call our blueprint callable function here in begin play. So I'm going to get overhead widget, and from overhead widget, I'm going to call get user widget object. That's the actual user widget that our widget component is using, which is this class, WBP overhead widget. So we can cast to that. I'm going to use cast to and choose WBP overhead widget. And as this class, I'm going to call our blueprint callable function show player net role. Now this takes a pawn, and I'm simply going to pass in a reference to self for this, as our character is indeed a pawn. So show player net role is going to get the net role, switch on that net role, and set the text for our widget based on that. So let's compile and hit play and see what happens. Now we see local role authority, and that's because we're playing a game with only one player. And in that case, we are the authority. We are on the server. Now I'm going to go into the viewport and take my overhead widget and move it up just above the head of my character. Now here's where it gets interesting. We can actually come up here to the 3 dots, and let's make sure that our net mode is set to play as listen server. And that way we're actually playing a game where one of the players is the listen server, so they're playing a game as the server, and the other players are clients. And we can change the number of players here. Now, when testing multiplayer games, it's a good idea to test with at least 3 players. That way we see all of the cases involved when it comes to net role. I'll show you what I mean. With number of players set to 3, I'm going to hit play. And now I have 3 individual game instances running. Now we see on the top bar for these 2 windows, netmode client 1 and netmode client 2. So these 2 instances of the game are clients, and the big window here in our editor is the server. Now the text is all jumbled up, so I'm going to move ahead a little bit. Now here on the server, take a look at this. We see that our local role is authority for all 3 of these, which is what we should expect. All pawns that exist here on the server are going to have local role authority. Now I'm going to get my client 2 here, and I'm going to expand the window a bit. And notice here the character I'm controlling has local role autonomous proxy. So my character here on my machine has local role autonomous proxy, and that's because I'm controlling it. So I'm going to run over here so we know which one is me. But on the server, I see that its local role is authority. Now I'm going to run over here to the other 2 characters, and notice they are both simulated proxies. So I'm looking at the versions of these characters on my machine, and those are going to be simulated proxies because they're controlled elsewhere. Now we can't tell from the local role which one is controlled by the server. We're going to find out later in the course how to determine that. But for now, it's very clear that all of the pawns that I'm not actually controlling on my machine have local role simulated proxy. And I can go to my other client here, client 1, and I should see the same thing. I should see that the pawn I'm controlling on my machine has local role autonomous proxy, and all the other pawns have local role simulated proxy. So now we have a feel for local role. So let's take a look at remote role. Now I'm going to go back to overheadWidget.cpp in our show player net role function. And instead of local role, I'd like to show remote role. So I'm going to change the name of this local variable from local role to remote role. And instead of get local role, from the pawn, I'd like to call get remote role. And this function does exactly what it sounds like. It returns an eNet role, only this time it's going to provide us with the remote role. So instead of switching on local role, we're now going to switch on remote role and set the string accordingly based on what that remote role is. Now, this f string down here, I'm going to rename to remote role string. And in the text, instead of saying local role, I'm going to say remote role. And for our function call to set display text, I'm going to pass in remote role string now. So let's compile this. And back here in the editor, I'm going to hit play. And now our widgets are showing us the remote role. Now check this out. Right here, I'm on client 2. And the remote role is authority. So we know what the local role is. For this character I'm controlling, it's autonomous proxy, and for those other two over there, it's simulated proxy. But the remote role is going to be the role on the server if we're not on the server. So it's going to be authority for all of these. Notice the same goes for the other client here. Remote role is authority for all three. Now let's look at the server. Here on the server, things are a little different. For the pawn I'm controlling, the remote role is autonomous proxy. And the remote role for these other two characters here is simulated proxy. So that's a little nuance to be aware of. On the server, the remote role is going to be autonomous proxy for the character controlled on the server, and simulated proxy for the other two characters. So we can always use this information to check the remote role in our C++ code to know which machine we're on, whether we're on the server or on a client. So in this lecture, we discussed the concept of network role and how a pawn's local role can be authority, which means that we're looking at the pawn that exists on the server, or autonomous proxy. That's the local role for a pawn that we're currently controlling on a client machine. We also saw that we have simulated proxy, which is going to be the local role for any pawns on our client machine that we're not controlling. We also saw the concept of remote role, and how the remote role for all pawns is going to be authority if we're looking at it from a client machine, and how the remote role for the currently controlled pawn on the server is autonomous proxy, and it's simulated proxy for the other pawns on the server that the server is not actively controlling. So we're going to use this concept of role throughout this course to determine which machine we're on in our code. Great job. I'll see you soon.